Welcome to my channel. In just days, 3i Atlas looks different. Shape, dust, light, all shifting at once. Today, I invite you to step into a quiet observation, not to find quick answers, but to look closely, because out there, a strange visitor is traversing the solar system, and in a short time, it has begun to look different. 3i Atlas is not a typical resident of our solar system. It is an interstellar object, a body that arrived from beyond the Sun's gravitational family, carrying the imprint of a different stellar neighborhood. NASA has released new findings today, and those findings do not feel like a routine update. They feel like a change in posture, because 3i Atlas looks different. And when an object looks different in a short span of time, the question is never only what it looks like. The question is what has changed inside it, what has been exposed, what has begun to fail, or what has begun to wake up. I will move through the evidence slowly. I will keep the language grounded in physics observation and what scientists can responsibly infer. But I will not pretend the implications are ordinary. Because in the new images in the shifting structure of dust and light around this nucleus, there is a feeling that something is unfolding, a surface breaking open. A deeper layer meeting sunlight for the first time in ages. And if that is true, then what we are witnessing is not just motion through space. It is transformation. A comet that keeps changing its face. In one frame, 3i Atlas is almost nothing. A faint brightening buried in noise near the sun, the sort of thing a casual viewer would miss entirely. In another frame taken far from that glare, it becomes a fuzzy orb with a suggestion of a tail, a short elongation of dust and gas being pushed away. This is not an illusion. It is physics staged differently each time. NASA's multi-mission campaign shows the comet through instruments that do not see the same universe. Some see visible light scattered by dust. Some see ultraviolet signatures of hydrogen. Some see what is normally hidden by the sun's brilliance. So when the title says it looks different, I hear something more precise. The comet is revealing different layers of itself depending on which eye is watching, and the agreement between those eyes is never guaranteed. That is the first kind of instability, a mismatch between what you think an object is doing and what it is actually doing. The early Hubble image that set the tone. There is a reason Hubble sits at the center of this story. In late July 2025, Hubble captured a sharp image of 3i Atlas and showed something specific, a teardrop-shaped cocoon of dust coming off the nucleus with a dust plume and the hint of a tail. That teardrop shape matters. A coma is not just a decorative halo, it is a map of forces. Sunlight heats one side. Ices sublimate. Gas escapes. Dust rides that gas like ash on a rising draft. The structure you see is the argument between sunlight, gravity, and outflow. From those Hubble data, astronomers constrained the nucleus size. The solid core could be as large as about 3.5 miles across, or as small as roughly 1,000 feet, with the important caveat that the nucleus itself could not be directly seen because the coma hides it. That uncertainty is not a weakness. It is a warning. When the nucleus is hidden, a comet can change dramatically while the core remains invisible. Fragmentation can begin inside the dust behind the veil, long before a clean split appears in an image. And this is not a slow visitor. NASA reports 3i Atlas moving through the solar system at about 130,000 miles per hour. An object that fast does not give scientists time to wait for clarity. It demands a campaign. 3. The campaign that turned the solar system into a laboratory. The new findings are not a single photograph. They are a stitched surveillance of an interstellar body in motion. NASA describes imagery from a dozen assets since the discovery date of July 1, 2025, with more opportunities ahead as the comet continues outward. And the most intimate views did not come from Earth orbit. They came from Mars. Earlier in the fall, 3i Atlas passed Mars at a distance of about 19 million miles, allowing multiple Mars assets to record it. NASA's Mars Reconnaissance Orbiter captured a close image while MAVEN took ultraviolet composites of hydrogen around the comet, separating that hydrogen from Martian and interplanetary hydrogen by speed. That detail is easy to overlook, but it is profound. When you can separate hydrogen sources by their velocity, you begin to isolate what belongs to the comet itself. You begin to turn it looks fuzzy into this is what it is releasing. Meanwhile, Perseverance on the surface of Mars caught the comet as a faint smudge against a star field. The point is not that a rover saw a comet. The point is that the comet was bright enough, active enough to be tracked across worlds. NASA's heliophysics missions also joined in because they can watch near the sun when ground-based telescopes cannot. NASA notes stereo imaging over mid-September through early October, and the joint ESA-NASA SOHO spacecraft observing in October as well. Pancha mission, designed to study the corona and heliosphere, revealed the comet's tail during late September into early October. This matters because the tail is a conversation with the solar wind. It is a visible trace of invisible flow. If the tail changes shape, that can be the comet changing or the solar environment changing, or both at once. Why it looks different now. So what did NASA release that makes looks different feel justified? A multi-angle, multi-wavelength portrait of the same object across months, including spacecraft that were never built to study comets as their primary mission. Psyche, on its way to a metal-rich asteroid, observed 3I Atlas for 8 hours in early September from about 33 million miles away, helping refine the comet's trajectory and providing more information about its faint coma. Lucy, headed for Jupiter Trojan asteroids, captured the coma and a smudge of tail from far greater distance with the comet circled in the frame. And Hubble returned. On November 30, 2025, Hubble reobserved 3I Atlas using its wide-field camera 3. At the time, the comet was about 178 million miles from Earth, and Hubble tracked it such that background stars streaked across the image. This is where the word different becomes more than aesthetics. At discovery, the comet's coma and activity were assessed under one solar distance, one geometry, one thermal state. By late November, the comet is in a different state of heating and outgassing history. Even if the nucleus stays intact, the surface layers can restructure. Jets can open and shut. Dust production can surge or fade. Grain sizes can change, which changes how light scatters and how bright the coma appears. A comet can look like it has changed its shape, when in truth it has changed its dust. And dust is the comet's autobiography. Each grain that leaves carries information about what the sun just exposed. The instability that scientists watch for. The title invites a feeling unstable, maybe splitting, maybe entering an anomaly. I will not claim a split that has not been confirmed in the released NASA text. What I will do is describe carefully why scientists treat rapid changes in a coma and tail as a potential prelude to fragmentation. A comet nucleus is not a monolith. It is often a porous mixture of ice and dust with voids, fractures, and weak layers. In interstellar space, it can remain cold for immense spans of time. Then, in the inner solar system, the sun forces a thermal shock. Heat penetrates. Volatiles wake up. Gas pressure grows in pockets. Jets carve vents. Those jets do more than make a tail. They apply torque. They can alter rotation. A changing rotation state can move active regions into or out of sunlight, producing sudden brightening or dimming, changing the coma's shape without warning. And if a crack propagates, the dust you see can briefly mimic a split nucleus. The coma can become stretched or layered simply because two vents are now operating on different sides. The danger, scientifically, is not danger to Earth. NASA is clear about the safe distance with closest approach to Earth, around December 19 at about 170 million miles. The danger is to interpretation. Because an interstellar object is a messenger from another planetary system and the message is fragile. If it fragments, the easiest measurements become harder. The nucleus becomes less accessible. Dust overwhelms the signal. The event becomes spectacular, but the chemistry becomes more difficult to isolate. That is why the campaign is relentless. This is a comet that will not stay. NASA notes it will continue on passing the orbit of Jupiter in spring 2026. What I think the new images are really telling us. When I lay these observations on top of each other, I see something that feels larger than any single instrument. I see a body that behaves like a comet in some familiar ways. Hubble measured a dust loss rate consistent with comets first detected at comparable solar distances, and saw a dust plume and tail features that resemble ordinary comet activity. And I see a body that is fundamentally unfamiliar in its origin. It is not bound to the sun. It is passing through. It is the product of another system's chemistry and history carried here by the gravitational chaos of the galaxy. So the different appearance is not merely a change over time. It is a difference in perspective. From Mars, ultraviolet hydrogen isolates one kind of story. From heliophysics missions, the comet becomes a tracer of solar wind and viewing geometry near the sun. From Hubble, the coma becomes a sculpted teardrop, a dust cocoon, and later a recaptured halo at a new distance under new conditions. A single comet becomes many comets depending on how you look. That is why it feels unstable, not because it is a threat, because it is a system in motion, and we are watching it with enough resolution to notice the motion. The next months and the moment that matters. There is a date in NASA's release that I cannot ignore. Closest approach to Earth is around Friday, December 19 at about 170 million miles. That is not closeness in the human sense. It is closeness in the observational sense. It is the interval when brightness, geometry, and access are briefly favorable before the comet continues outward and the opportunity begins to slip away. If 3I Atlas is going to reveal a decisive clue, a chemical signature that does not match local comets, an unexpected dust behavior, a change in activity that hints at a layered interior, it will do so while we still have eyes on it from many positions. That is why the phrase "new findings today" is not a headline flourish. It is the reality of a moving target, a comet that evolves as you watch, a visitor that changes its face while you are still learning its name. And if it does fragment, the evidence will not arrive as an explosion. It will arrive as a subtle disagreement, a tail that kinks, a coma that elongates, a brightness that does not scale the way models expect, the kind of difference that makes scientists stop speaking in complete sentences. For now, the most important fact remains the simplest. NASA is watching 3I Atlas with nearly every kind of eye it has, because an interstellar comet is not just an object. It is a sample of another solar system delivered at high speed, wrapped in dust and already changing. And today, in the new imagery, it looks different, which means it is still talking. And this is where the story becomes dangerous in the scientific sense, because the next images may not simply show a brighter coma or a longer tail. They may show a change in structure, a shift in symmetry, a new layer exposed. So in the next part, I will walk through what the latest measurements actually indicate, what models can explain, and what would count as the first true sign that 3I Atlas is entering an unstable phase.